Hello everyone, this is Bhuvaneswari. We are doing a project on IoT based home automation system. My teammates are P. Modni, D. Narendra, B. Dileshwara, and B. Pawan Kumar. Now let's coming to table of contents. We have C programming, C++ programming, embedded C, embedded systems, Arduino UNO, control flow, demo, and conclusion. Now let's coming to C programming. What is C? C is a general-purpose programming language created by Dennis Ritchie at Bell Laboratories in 1972. It is a very popular language despite being old. The main reason for its popularity is because it is a fundamental language in the field of computer science. C is strongly associated with Unix as it was developed to write the Unix operating system. Basics of C has include is a preprocessor directive that includes the header file in the C program. The studio.stdio.h is a header file where all input and output related functions are defined. The main function is an entry point of a C program. The C program's execution starts from the main function. There are two types of commands, single line and multi-line comments. Comments are ignored by the compilers. The scanf function is used to various types of inputs from the user. Data types. The data types specifies the type and size of the data to be stored in a variable. Data types are categorized in three sections: the basic data types, derived data types, and user-defined data types. Identifiers. Identifiers are user-defined names for variables, constants, functions, etc. The following are the rules for defining identifiers. Keywords cannot be used as identifiers. Only alphabets, underscore symbol, and digits are allowed in the identifier. The identifier must start either with an alphabet or an underscore. The same identifier can't be used as the same name of two entities. Identifiers should be meaningful and descriptive. Operators. Operators are the special symbols that are used to perform specific mathematical or logical operations. Conditional statements. C language provides the following conditional statements. First one, if statement. Next, if else statement. If else if statement, nested if else statement, and switch statement, and ternary operator. Loops. Loops are used to execute blocks of one or more statements respectively a specified number of times or till a certain condition is reached. The following are the loop statements in C language: while loop, do while loop, for loop. Jump statements. Jump statements are used to transfer the flow of the program from one place to another. The following are the jump statements in C language: go to statement, break statement, continue statement. The go to statement transfers the program's control to a specified label. You need to define a label followed by the colon. The go to statement can't transfer the program's flow up or down. The break statement can be used with loops and switch statements. The break statement terminates the loop execution and transfers the program's control outside of the loop body. Continue statement is used to skip the execution of the rest of the statement within the loop in the current iteration and transfer it to the next loop iteration. Now coming to array. An array is a collection of data items of similar data type which are stored at contiguous memory location. The data item may be primary data types like int, float, character, etc., are user-defined types such as struct or pointers can be stored in an array. It can be of two types. One-dimensional array. A one-dimensional array is a single list of data items of the same data type. Next, multi-dimensional array. A multi-dimensional array, such as a two-dimensional array, is an array of arrays. C++ programming. What is C++? C++ is a high-level general-purpose programming language created by Zernez Strostrup at Bell Labs in 1983. It is widely used for building software, games, operating systems, and performance critical applications. If you need high performance and precise control over memory and other H or W resources, then C++ would be nice choice. Few applications of C++ are video games, high performance financial applications, graphical applications, and simulations. Data types. Data types define the type of data a variable can store. Every variable in C++ must have a data type. C++ is a statically typed language, which means the data type of a variable is fixed at compile time and cannot change later. First, integer. It stores whole numbers. Example 10 or -5 or 0. It can be used for counting, indexing, or arithmetic operations. Integers take 4 bytes of memory. Next, floating point. It stores decimal numbers with single precision. Example 3.14, 2.22, etc. Useful for measurements, fractions, and approximate calculations. It takes 4 bytes of memory. Next, double. It stores decimal numbers with double precision. It is more accurate than float. Example 3.14159. It is used when more precision is required in calculations. It takes 8 bytes of memory. Fourth one, character. Stores a single character. Example character A, character B, character name. Usually enclosed in quotes and can be used in text processing. It takes 1 byte of memory. Next, Boolean. It stores only true or false values, commonly used in conditions and logical operations. It takes 1 byte of memory. String stores a sequence of characters, example hello, used for text, names, messages, or sentences. We have to include string header file for using string class. Now coming to embedded C. Embedded C is a programming language that is used in development of embedded systems. Embedded systems are specialized systems designed to perform very specific functions or tasks. Embedded system is the combination of hardware and software, and the software is generally known as firmware, which is embedded into the system hardware. Embedded C is used to program a wide range of microcontrollers and microprocessors. Key characteristics of embedded C. First one, efficiency. In embedded C, we can create an efficient code to optimize the limited resources available in embedded systems. It aims to minimize memory usage and maximize performance. Direct hardware interaction. Embedded C allows programmers to interact directly with hardware components such as microcontrollers, sensors, actuators, and other peripherals. This direct interaction facilitates precise control over the hardware, critical in embedded applications. Low level programming. Embedded C involves low level programming, which deals with the hardware specific details like memory addresses, I/O ports, and register manipulation. This level of control is essential for efficiently managing hardware resources. Real time operations. Embedded systems often operate in real time environments, requiring precise timing and response to events. Now let's coming to embedded systems. An embedded system is a specialized computer system that is part of a larger mechanical or electronic system designed to perform a specific function. It is a combination of hardware and software, often containing a microcontroller or microprocessor, memory, and input output devices. Examples include the control systems in a microwave, the anti-lock brake system in a car, or the electronics in a washing machine. Key characteristics: specific function. Unlike a general purpose computer, an embedded system is built for a dedicated purpose, such as controlling a car's engine or displaying a time on a digital watch. Integrated. It is embedded within a larger device and is not a standalone computer. Real time constraints. Many embedded systems must operate in real time, meaning they have specific timing constraints to control physical operations precisely. Hardware and software combined. It consists of both the physical hardware, processor or memory, etc., and the embedded software that controls it. Now coming to components, we have processor, memory, input output peripherals, and communication ports. Now let us coming to Arduino UNO. The Arduino UNO is a microcontroller board based on the Atmega 328. It has 14 digital input-output pins, 6 analog inputs, a 16 MHz ceramic resonator, a USB connection, a power jack, an ICSP header, and a reset button. It contains everything needed to support the microcontroller. Simply connect it to a computer with a USB cable or power it with an AC to DC adapter or battery to get started. Microcontroller used in this Arduino UNO is at Mega 328 pin. It was operating at the voltage of 5 volts. The input voltage is 7 to 12 volts. Input voltage limits from 6 to 20 volts. Digital input-output pins are 14, of which 6 provide PWM output. Analog input pins 6 DC current per input-output pin 40 milliamperes. DC current for 3.3 volts pin is 50 milliamperes. Flash memory is of 32 KB, of which 0.5 KB used by bootloader. SRAM is of 2 KB, EEPROM is of 1 KB, and the clock speed is 16 MHz. This is the control flow in our project. And next, this is our project demo. It shows minimum basic code for our project. And next,
we look into the code. Here we have the blink template id. These are called as the blink credentials. And here for the serial tank we have included serial tank library, and for ethernet we included ethernet library, and for ldr the LDR library, and for temperature system library. Then we have created Blink. Right, Blink is used to control the components which are connected to Blink, count them through Wi-Fi and control them through the Wi-Fi. So this function is for the cooler and this function is for the heater. And in the same way, we have created a function for the inlet wall and the outlet wall, and we also added a handle temperature function, so that if the temperature is greater than 35, the heater automatically gets off. And we also added a handle tank to off and on the inlet valve when volume is less than 2000. So capacity of our tank is 3000. If the volume of the tank is less than 2000, we automatically on inlet wall, so the tank gets filled. And to get the readings in the Blink app, we have write this Blink virtual rate. So temperature can read by Blink app and we can display them on Blink app. So here we implemented and initialized all components which we used in while loop and functions. Here we have initialized all the functions. So these are the sub codes to the initial pins. So let's go into our project. So this is our Arduino. We have to load our hex file. As I have already loaded my hex file. So this is the output. So initially the temperature is 27.34 degrees centigrade. That is the room temperature. So we can adjust the temperature. So we can adjust the brightness of the garden light. So we can't simulate the sunlight. We have this bar display that tells about the sunlight. If the sunlight is less than, the resistance is more than the garden light is high. If the sunlight is more than that of resistance, which is low than the garden light, is dull. So this is a fan to control our heater and cooler. This is Ethernet and this is LCD display. It's our serial tank. I connected our serial tank to Arduino, got connected to COM2. So now let's connect them via internet and let's see how it works. So this is our first run our program, load our hex file. I'm loading it. So we have loaded our text file. Now we have debug it. After debugging it, we can see we will get home automation, that is starting from the LCD display, and this is the volume of serial tank and this is the temperature. So we can see the serial tank is getting filled. So we can control the serial tank from the Blink app. So it is telling our project is online. So here we can see the buttons. So if we off the inlet wall, we can see that inlet wall water.
Let us coming to conclusion. Using Blink IoT application and PIC SimLab simulator, we simulated home automation where LED temperature system, serial tank resembles light, heater, cooler and water tank in real time. CLCD acts like a dashboard used for displaying the events. Widgets from Blink IoT app like button widgets are used to control heater, cooler and inlet valve, outlet valve. Gauge widgets to display the temperature and volume of the water. Hence, the project provides perfect solution for home automation. Thank you for listening this.